So let us formally define what we mean by uncertainty of an observable. So suppose Q is some observable. So that means that it is a Hermitian or a self-adjoint operator, and that its eigenvalues are real. So if phi I are the eigenfunctions of Q, then Q acting on phi I will give us the eigenvalues small qi times phi I. And qi these are real. Now suppose we have some arbitrary state psi. So this is not necessarily an eigenfunction of Q. So we want to find out what is the expectation value of the Q operator with respect to this state psi. So we want to compute this. So the definition of the expectation value is this object. So we know that the expectation value by expanding psi in terms of phi I, we can show that this will be sum over I, the probability that when we do an experiment on the wave function psi for Q, that we obtain the value Qi times Qi. So this is what it means to take an average. So if Qi is not an eigenfunction of Q, so if psi is not an eigenfunction of Q, there will be a probability distribution with some kind of a spread. So what do I mean by that? So let's take an example. So for example, suppose the eigenvalues of Q, so these are Qi, they are given by this list, say 1, 2, so we have 10 eigenvalues. And to suppose that the probability that when I do an experiment on psi, I get Qi, the corresponding probabilities are 1 by, say, 29. So these are the probabilities of the corresponding eigenvalues. So we can now represent these eigenvalues in terms as graphically. So suppose that we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then this is the first one. Its probability is 1 over 29, and the probability of finding 2 is 3 over 29, 10 is 2 over 29. Now the average Q you can compute, and it turns out to be 148 by 29, or 5.10, 5.10, 5.1034. So the average value falls between 5 and 6. Of course, the average is not the only number that characterizes this data set. So the average is not the only number that characterizes this data set. Another number that characterizes this data set is called the standard deviation or the mean deviation. And it characterizes how the most probable values that you're going to get if you do an experiment around the average. So what is the definition of the mean deviation or the standard deviation? So we know that the standard deviation is defined to be delta Q, and that is the difference between whatever the experiment is, the deviation of the experimental value from its average, and then what we do is that we take its square and then take the average of the square, and then we square root the average. So this is the definition of the standard deviation, or as we shall say, the uncertainty. And it's very easy to show that this is equal to in other words, we have delta Q squared is the average of Q squared minus the square of the average of Q.